This is the vernier force plate. It allows us to measure larger forces than our dual range force sensor. You might use this with kind of human-sized forces. It kind of looks like a bathroom scale, so you can stand on it. So you might do things like measuring your hang time of a jump. Another common activity, if you have access to an elevator, is ride the elevator up and down and look what happens as the elevator stops and starts there. Another common usage might be with Newton's third law. So you might take a pair of these and push them against each other and measure that action-reaction pair. So this is the actual force plate itself. It comes with some handles, and the handles are designed to be mounted either on the front or on the back. So if you are using something like that Newton's third law lab, you might want to attach the handle and be able to do that. To attach the handle, it's not hard to do. You take the handle, and you've got the holes here, and you can line them up with the holes. And then you take your thumb screws and you screw those into the force plate. And now that the handles are mounted, I can actually hold this in my hand and I can use it to push against something. So if I had a set of these, maybe two students are pushing against each other to measure that action-reaction pair. Another usage of this might be that you actually hang it on the wall, and there's a hole in the back that allows you to hang it on a mount so that you could do things like throw a ball or something at it. Now I'm going to use this by dropping a ball on it and just measure the impact time and the impact force with that. When I do this, I don't want the handles attached, so I'm going to remove the handles before I do my data collection. One thing about the force plate is that it's a dual range sensor. And so there's a sensitivity switch here that allows you to determine how sensitive you want the device to be. So if you're going to jump up and down on it, you may want it on one setting. If you're going to do something like I'm going to do and drop the ball on it, so it's a lot less massive, then I might want to have it on a more sensitive setting there. So I've got mine set on the more sensitive setting, and I'm now ready to do my collection. So the force plate is an analog sensor, so I need to plug it into one of the analog ports, like channel 1. So now that we have it plugged in, we see that we have a force there on channel 1, and we're getting a reading there. Now, one common thing that you might do with a force plate is zero the force plate before you use it. It's like tearing a balance. You zero your bathroom scale before you get on it, and so it's a common usage. And so to do that, you tap on the meter, and you can go to 0, and now it's reading close to 0. So at this point, let's take a look at our collection parameters. I have a time base, so it's going to look at force as a function of time. The default sample rate is 500 samples per second, and the duration is 10 seconds. The duration is fine, but my rate is not quite fast enough for me. I would like to speed this up to the maximum rate for the force plate. And to do this, I just go up and tap where it says rate. And I'm going to go and tap there. And instead of it being 50, I'm going to do 500 samples per second. I say done, and I'm fine with that, so I say OK. And now I'm ready to collect data. Now, one thing about the ball I'm using a ball that's soft, so it's a kick ball, and so that I'm trying to extend the collision time a little bit. Sometimes people want to drop something that's a really, really hard ball. They want to drop a golf ball, and the problem there is that it's so hard that the impact time, there's really not time enough for the force plate to react. I mean, the mass of the plate itself, it just doesn't react. So we suggest if you're going to do a ball bounce on it, that you use something like a kickball or a basketball or something like that that gives kind of an extended impact time. So we're ready to collect data. So I will press the collect button, and then we'll drop the ball. So hold it up and drop the ball. And what's happening here is that the data collection was so fast that the LabQuest can't draw the graph, and so until the data collection is complete, it doesn't draw the graph. Now data collection, it's got all the data and can draw the graph, and we get a nice little collision experiment with our ball and the force plate. So let's take a look at this portion of the graph. There's our collision, and it happens just in a little piece of the time there. And what I would like to do is zoom in on just that portion of the graph to be able to analyze that. So I'm going to come in here and maybe tap and drag with my stylus. This is a case where I might use the stylus because I'm trying to get in fairly tight there. I can do graph, zoom in, and then I need to zoom in a little bit more. So I'm going to come in here and zoom in from, say, here to here, graph, zoom in again, and so there I have a nice curve. And I might want to analyze this with an integral. I might want to be able to get the area under the curve to get the impulse for the collision. So to do this, I just go up to Analyze, and because I've highlighted that region, when I do the integral, it's going to use just the data under that curve, and then I get my integral there. We've discussed some use cases with the force plate, so doing things like measuring hang time, riding elevators, and doing third law experiments, and so that's the typical use case for the force plate. So if you need to measure things like that, the force plate should meet your needs.